Hi, my name is Alan Baker. Today I'm going to talk about Zigbee Networks. I'll provide an introduction to XBees, then I'll go on to talk about network topology. Then I'll provide a comparison between XBee Series 1 and 2, although Series 3 is now available. I'll talk about that series in a later video. I'll then provide a diagram of all the sensor types available that can be attached to XBees. I'll then talk about the two modes of operation, AT mode and API mode. Finally, I'll provide a video of XBees in operation forming a Zigbee network. XBees are small electronic components that pass information between themselves by means of a formation known as a Zigbee network. The information that they pass is mostly from various types of electronic sensors that are connected to XBees, which are being configured as end devices. They communicate with each other working through the same frequency, usually set at 2.4 GHz, by means of a personal area network ID, which you can see from the bullet point in front of you, covers a vast range. XBees come in many designs. Here I've just illustrated two of them. The whip or wire antenna is an excellent choice for beginners. This is because the maximum transmission is roughly the same in all directions, provided the antenna is facing roughly 90 degrees from the XBee. I'll use the chip XBee type in my demonstration. This is mainly because I have more of these than the whip or wire antenna type. Chip types are smaller and stronger than the whip or antenna types. However, lacking an antenna, the outdoor RF range is not as impressive. They are, however, suited to products for indoors and can be designed to fit into sockets. They are also suitable for the wearable products market. Networks are generally composed of three components: a coordinator, which controls other devices, a router, which passes messages between the other two devices, an end device, which communicates with the router and is connected to sensors. The most popular networks are a pair, a star, a mesh, and a cluster. This is a comparison between XBees Series 1 and 2. For specific information, consult the relevant datasheet. The table also shows a comparison between the normal XBee types and the professional XBee types. While the normal types have a maximum outdoor RF line of sight range of between 100 to 120 meters, the professional types have a much larger range of 1600 meters. This is 0.994 of a mile. However, unless the XBee is placed high above ground level, a modern city or town would reduce this range. Here are some examples of sensor types that can be attached to XBees configured as end devices. XBees in Series 1 and 2 come with two modes of operation. These are AT or attention mode, which is basically a one-to-one where the coordinator is connected to a router or an end device. The second mode is API or Application Programming Interface mode. Here the coordinator can be connected to many routers and many end devices. Also, through packet data, the coordinator can be connected to a router which, in turn, is connected to many end devices. Next is a video example showing simple data transmission between a coordinator and a router. One XBee is programmed as a coordinator at AT mode and the other as a router at AT mode using the Digi XCTU application. On the underside of every XBee are high and low addresses. These are unique to each XBee. In this video example, the coordinator's high and low addresses are programmed into the router, and in turn the router's high and low addresses are programmed into the coordinator. They are both programmed to use the same PAN ID of 2001 within the frequency of 2.4 GHz. XBees are connected to the computer by means of an adapter board and a cable. These items can be searched for on the internet. I'm using a popular adapter board and a cable with a standard USB-A to a mini B connector. To program the XBees, we need a coordinator and a router. I'll start with the coordinator. The first thing we need to know is the modem reference. This you will have located earlier on the underside of the XBee. Then select the function set. We then need to program the PAN ID that both XBees will communicate with. The next thing we need to program is the destination high address and destination low address of the router. And when I program the router, this will contain the destination high address and the destination low address of the coordinator. I'll now program the router. Because I've already explained what to do, I'll play some background music this time. Okay, now putting everything together, the first laptop has an XBee programmed as a coordinator. The second laptop has an XBee programmed as a router. Now Digi has a new app for XBees, but since I'm using Series 2 and this is a straight swap of data, so I'll stick to the old app on this occasion. So now let's wake up the coordinator and the router and see if I can transmit information between them. And if successful, I'll have formed a Zigbee network.